So today, guys, we're going to talk about experimental probability in comparison to theoretical. So experimental, just like it sounds, guys, does have to do with experiment. We're actually going to go through the action of rolling of the dice or spinning the spinner and analyze our results. So it's still going to be a ratio of events occurring compared to the total trials. So the trial, guys, it's the actual experiment. Just like I mentioned, this is literally when we going to say, let's toss that coin. Let's spin that spinner. Okay, so our ratio is going to look very similar. Wanted number, wanted color, whatever we're discussing, out of trials. If you might say, well, did we do the same thing for the other probability? So guys, the other probability was theoretical probability. So it has to do with the word theory. So what are we expecting to see? What are our expectations? What is the theory? So back to that coin, in theory, all coins have heads and tails, and both sides have 50-50 chance. That's theoretical thinking behind this probability. So just as a reminder, theoretical probability, we always wrote this as ratio of wanted outcomes to possible choices. Okay, so we would say I want number 6 versus what are my total number of numbers? How many sides do I have on that cube? How many sections are on that spinner? So again, very similar. We still look to what are we wanting to analyze, what color, what number, and so on. But what is changing? We had total choices. So all of our number cube had 6 sides every time. And then, so with experiment, we are going to be looking at the trials, not the choices. Okay, let's take a look at the actual example. So it says, what is the probability of flipping a coin and landing on tails? You might say, Miss Hendricks, we've been there, done this. It is 1/2, 100%. And so, have we actually done it, guys? No. So this is our theoretical probability. So we know that each side has 50-50 chance of happening. Okay. However, let's look at this statement, guys. It says you flip a coin 20 times and land on tails 9 times. What is the experimental probability landing on tails? Okay, so you actually did do the act of flipping of the coin. So remember, tails, so probability of tails would be 9. That's what we're asked about. Not out of 2. But now we're going to look at our trials out of 20. So let's go take a look at the percent value. So we did say it's 50-50 chance. However, now 9 out of 20 percent out of 100. Hopefully you guys are seeing the pattern, the relationship here. And so that's going to be 45%. Okay, so we have, according to our experiment, less chance of getting the tails. Okay, so theoretical and experimental probabilities for the same event are often not the same, and it is okay. We just want to make sure that we understand the difference. So it says, because theory is only how it could happen, an experiment an extra is about actual result. Okay, so that's going to be huge thing that I want to make sure that you guys are looking for when you're reading the statements. So you guys are going to see that you're not just going to say or give or have information that says you flip a coin. It will say that you have done it so many times. So they actually had an experiment. And so that would be one of the ways to distinguish, is it theoretical or is it experimental? You're going to have statements that would say you spun the spinner 50 times, you flipped the coin 10 times, and so on. So what we're going to do today, guys, is we're actually going to have an experiment. For those of you who are watching this video at home, I hope you guys can grab a coin that you're going to use, and you are going to use the flip side of this note. As you notice, I've kind of folded it in half. So I'm going to flip to this side, and regrettably we cannot work with a partner, even for the kids who are here in class. So by yourself, sorry, but I do want for us to have an experiment, and then on Tuesday in class we're going to see what kind of values we came up with. So just to kind of start your experiment, again, if you're at home, please grab a coin so you can flip the coin. For those of you here in class, you guys have a virtual tool that I have attached on Canvas. You, all of you guys are welcome to use it. So it's not just for face-to-face learners. So what you guys gonna do is you're gonna use these tables to organize your results. So it says flip the coin 10 times. So you guys are going to start flipping the coin 10 times and going to write down your results. So don't have a coin handy, but as I'm trying to find it, I don't have a coin with me, but let's imagine I have flipped it 10 times. You're going to use your own example. But I would say, okay, tails, tails, heads, tails, and so on. And you're writing down what you guys come up with, okay? And then you're going to scroll down to this question right here. I know they kind of numbered up really funky. They're asking you, what was the experimental probability? Landing on heads. So you're going to say, okay, I have landed on heads 2 times or 3 times or whatever your results are. Okay, so in class, we're going to take time to really compare what were some of our numbers. Were you getting close to theoretical probability or not? So then you guys going to continue flipping this coin and filling out this table. So 10 times here. Another 10 times here, and then yes guys, you're gonna flip the coin 30 more times, and you have a total of 50 flips. And so then you're going to add them all together, for this question right here, it says after 50 trials, what was the experimental probability of landing on heads? Again, everybody's numbers are different. So, according to your experiment, guys, I would like for you to do some comparison. It says, did the experimental probability of landing on heads change as the number of trial increased? So, I would just say compare your probability of heads out of 10 versus probability of heads out of 50. Whoop, sorry guys, you didn't see my numbers, my writing. So again, this is where you would say yes. One of the ways to compare is using the percent. You would say, yeah, my numbers could be different, but is it going to be equaling to the same percent? And then you guys would make a prediction based on your experiment. So we've done predictions already. You guys are doing an outstanding job with those. So that's the last question for your note. So then we can compare our results tomorrow. It says, what if you flipped it 50 more times? What would you expect to happen to the experimental probability? So what are your values for 50 trials? And then you are making prediction. So predict out of 100 trials. Okay. Please be ready to share these responses tomorrow during our Zoom class, and we're going to see what kind of variety of results we get with our experiment.